Now students, now you have understood what are ionic compounds and what are the properties of ionic compounds. Now let's further talk about solubility, how to determine the solubility of ionic compounds. Let's get started. So when we talk about solubility, let's see what are the conditions for ionic compounds to be soluble. Suppose you have a MX compound, which is obviously an ionic compound in a solid state, which is getting converted into the aqueous compound and ultimately into ions. So when your solid MX is present, okay, that will absorb energy as shown on your screen, and they go into the gaseous ions, as this is nothing but your lattice energy. So the energy which is absorbed is lattice energy. Now this ionic gaseous atom will combine together, as you can see on the screen, and they form MX, which is your ionic compound in an aqueous state. And which energy is released over here? Here hydration energy is released. So to understand solubility, there are two factors, that is lattice energy and there is hydration energy. So these two relations are important. Now let's see what is the relationship between them and how it is responsible for solubility. So remember this equation. If lattice energy of any compound is greater than hydration energy, look carefully, if lattice energy is greater than hydration energy, that means your lattice energy which is absorbed is greater than the hydration energy. At that point your compounds will be insoluble. But if your lattice energy is less, if your lattice energy is lower than hydration energy, then the compounds will be soluble. So remember it like this: if lattice energy is more, hydration energy is less, then your compound will be insoluble. If lattice energy is less, hydration energy is more, then your compound will be soluble. So let's take example of beryllium sulfate, that is your BeSO4, okay, and BaSO4. Okay, let's compare both of them. Okay, your beryllium and barium sulfate is common. If you look carefully, your beryllium sulfate is soluble in water. Remember this, your beryllium sulfate is soluble in water, while your barium sulfate is insoluble in water. Now why so? Because obviously here the two terms are going to come again, that is your hydration energy and your lattice energy. Again these two terms you have to compare. So let's understand by what means. So barium or beryllium sulfate, okay, you have BeSO4, correct? So when we talk about Be2 plus ion and when we talk about Ba2 plus ion, if we compare both of them, students, which is larger in size? Obviously barium is larger in size and beryllium is quite smaller in size, that is around 150 to 152 picometer, and barium is around 250 to 260 picometer. These are general values that I am giving you. Okay, so we can say that your beryllium ion is smaller than barium ion, and hence hydration enthalpy is higher in whom? Beryllium. Why? The hydration enthalpy is higher because the size of beryllium is smaller while the size of barium is higher. So hydration enthalpy is less in barium, but what is greater than? The lattice enthalpy is greater. Lattice enthalpy is greater in barium, correct? And in beryllium, hydration enthalpy is greater. So according to this, we can say that your barium or beryllium sulfate is soluble in water due to higher hydration enthalpy, and your barium sulfate is insoluble in water due to higher lattice enthalpy. So we can say that barium sulfate, the hydration enthalpy is less, and in beryllium sulfate the hydration enthalpy is more. Hence beryllium sulfate is soluble in water and barium sulfate barium sulfate is insoluble in water. I hope this is clear to you. Now similarly you have question over here. So what is the order of solubility of halides of barium? Again you have to compare barium fluoride, barium chloride, barium bromide and barium iodide. So barium is again common. Barium is common in all of them. Only difference is what? Difference is of size of your electronegative atom. So your fluorine, chlorine, bromine and iodine, which has least size? Which has least size? Obviously fluorine has the least size, so it will be more soluble, obviously. So fluorine, then chlorine, then comes bromine and then comes your iodine. Hence your barium fluoride will be most soluble, then comes your barium chloride, then comes your barium bromide and then comes your barium iodide. So your correct answer is option A.